This video is on Chapter 4 on Lesson 4.1, so Lesson 1, Terminating and Repeating Decimals. Okay, first we're going to start off with something that I had you guys do in your notebook called the power triangle, which is fraction to decimal, decimal to percent, and percent to fraction. So all of these are called rational numbers. And all of these rational numbers can be converted into each other. So that's what we're going to get working on. So the first part is fraction to decimal. So for the first example, I have 7 over 20. Now, to convert a fraction to a decimal, we have to do the operation of division. You have to divide. Because what this is really saying is 7 divided by 20. So when you go from a fraction to a decimal, you need to divide. So that means you need to do long division. So let's do that. Now I have that saying, top in, bottom out. I'm actually going to write that for you. Top in, bottom out. So what that is telling us is that the top, which is our 7, is going to go inside the house, and our bottom, which is the 20, is going to go outside the house. So now you start the long division. So how many times does 20 go into 7? None. So we put a 0. 0 times 20 is 0. 7 minus 0 is 7. Now there's nothing left to bring down. So we have to add two things. First we add a decimal. We bring the decimal up in our answer always. And then we also have to add a 0. And that 0 needs to come down. So the decimal goes up, the 0 comes down. So now you ask yourself, how many times does 20 go into 70? Well, it doesn't go in evenly, but 20 times 3 gives us 60. So I think that's the closest because 20 times 4 would be 80 and that's too big. So let's try 3. 3 times 20 is 60. 70 minus 60 is 10. Okay, now we have to add another 0 to bring down because there are no other digits there. 20 goes into 100 evenly 5 times. Because 5 times 20 is 100. So we have our remainder 0. So what this is telling us is that 7 over 20, okay, is equal to the decimal 0.35 or 35 hundredths. Now this answer here, 0.35 or 35 hundredths, is called something. This is called a terminating decimal. And what that means is that, well, it terminates, okay? It ends, so it does not go any further. 0.35 is a terminating decimal. It stops right after 5. Next example, we have 8 1/3. Okay, so now we have to change this mixed number into a decimal. Okay, but don't be scared. What we need to do is we need to break this up. Okay, because what this is really saying is 8 plus 1/3. So the 8 is the whole number. We can leave that alone for now. What we need to deal with at this moment is the 1/3. We need to change 1/3 into a decimal. So that's what we're going to do. In order to do that, we need to do division. Top in, bottom out. Top is the 1, bottom is the 3, bottom out. So 3 goes into 1 0 times. 0 times 3 is 0. 1 minus 0 is 1. Now there's nothing left to bring down. So in this case, we need to add our decimal. Oops. What's going on here? Bring up the decimal. Add our 0. and bring down the 0. So now we have, how many times does 3 go into 10? 3 goes into 10, not evenly, but it goes in 3 times because 3 times 3 is 9. 3 times 3 is 9. We subtract. 10 minus 9 is 1. There's nothing to bring, so we have to make something to bring, so that's why we add our zeros. 3 goes into 10 again 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down another 0. Now if you notice, something is going on here. It's going to keep going and going and going, because if we did this again, 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down the 0. So, what this is called is a repeating decimal. Now I'm going to write that down. That is called a repeating decimal. So when you have a repeating decimal, there's a certain way you can write it so that you don't have to write 3's for the rest of your life. So what you would do is, you'd write the number that repeats, and you would put a bar on top of it. That is called bar notation. So now, since we found out that 1/3 is 0.3 repeated as a decimal, let's go back to our original problem, which was 8 1/3. So to write that as a decimal, okay, we have our 8 plus 0.3 repeated. So basically what this is doing is, this 8 is a whole number, right? Now the whole number would go in this spot. So all you would do is you would put 8 in place of the 0. So 8 1/3 as a decimal turns out to be 8.3 repeated. Okay, so now we're up to the opposite. We're going backwards. We're doing decimal to fraction. Okay, so before we did fraction to decimal, now we're doing decimal to fraction. So what we need to do here is, we have our decimal for our first example, which is 0.3 or 3/10. And what we do is, we look at the last digit in this decimal. Now in this case, the last digit is the 3. We ask ourselves, what place value is that 3 in? That 3 is in the 10ths place. So since it's in the 10ths place, as your fraction, you're going to write 3 over 10. Now you have to ask yourself, well, does that simplify? It does not, so that is your final answer, 3 over 10, or 3/10. Example 2, 0.25 or 25/100. So again, you do the same thing. You look at the last digit in the decimal, which in this case is a 5, and you ask yourself, what place value is the last digit in? Tenths, hundredths. So since it's in the hundredths place, what you're going to do is you're going to write 25 over 100. Okay, and then you have to ask yourself, well, can that be simplified? Yes, it can. And whenever you see 25, I want you to think of quarters. Now, how many quarters are in $1? There are 4, right? So in this case, what we can do is, we can divide both numbers by 25. 25 divided by 25 is 1. 100 divided by 25, so think about it, how many quarters are in $1? 4. Okay, because 4 times 25 would be 100. 1/4. And that cannot be simplified, so that is your final answer. Third example is negative 2.66, or negative 2 66/100. So this one's a little different because we have a whole number and a negative. Now, don't worry about the negative. We can worry about that at the end, and don't worry about the 2. What we're going to do is we're going to focus on what is to the right of the decimal. So the last digit, which in this case is the second 6 here, we have to figure out what place value that 6 is in, right? That place value is the hundredths place. So again, we're only dealing with the numbers that are to the right of the decimal point, because negative 2 is going to be our whole number, And that whole number is going to go in place of the fraction, because remember, we're turning the decimal into a fraction. So back to this, 6 is in the hundredths place. So we're going to write 66 over 100. Now we have to ask ourselves, can that be simplified? Yes, it can. And if you can't think of a number, what you can do is, if both numbers are even, which they both are, you know that you can always divide them by 2. 66 divided by 2 is 33. And 100 divided by 2 is 50. Then you ask yourself again, can that be simplified? That cannot. So since that's simplified, we have to remember our whole number. So that whole number will go right in the front of our fraction. So our answer is negative 2 and 33 over 50. Next is decimal to percent. Okay, so what you do is this. When you have a decimal and you want to change it to a percent, all you need to do is you move the decimal point 2 spaces to the right. Now when you do that in this case, because we had 0.7 or 7/10, there is no number after the 7. So what goes in that loop? A 0. So your answer is 70%. Next we have 0.625 or 625 thousandths. So we do the same exact thing. We always move 2 spaces to the right from changing our decimal to a percent. 1, 2. So now for our percent we have 62.5%. Third example is 0.3 repeated. Well, that's a little interesting. What we have to do is we have to write it out. We have to write out 0.33333, and we can stop there because we know that the bar on top of that 3 means that the 3's go on forever. Okay, so once we wrote it out a little bit, we do the same exact thing. We move 2 spaces, well, the decimal moves 2 spaces to the right. 1, 2. Now in this case, your answer is going to be 33.3 repeated. Now, usually it's not going to, you never see percent looking like that. So I'm sure they would say, okay, round to the nearest tenth or the nearest whole number. So in this case, we're going to round to the nearest whole number. Our whole number is 33. So when we're rounding to the nearest whole number, or any number, you look to the number to the right of it, which in this case is a 3. Now, the 33 is either going to stay 33 or it's going to go up to 33. It depends on the number to the right of it. So now, since this is a 3, you know the saying, 5 or higher up the score, 4 or less, stay at rest. So it's 4 or lower, so we're going to stay at rest. So we're going to keep it as 33. So our answer is going to be 33%. Percent to decimal. Now, this is just the opposite. With going from a decimal to percent, we move the decimal point 2 spaces to the right. So now, since we're going backwards, percent to decimal, we're going to move the decimal point 2 spaces to the left. Now here we have 75%. Okay? Now this is the whole number, and as you all know, the decimal point, if there is none, is always to the right of the number. Okay, so again, we're going to move 2 spaces to the left. 1, 2. So, 75% as a decimal will be 0.75 or 75 hundredths. Okay, let's look at this one. 14.5%. Again, we take our decimal point, we move it 2 spaces to the left this time. So now our decimal is 0.145 or 145 thousandths. Okay, and next one we have 2%. Okay, so we do the same thing. We take our decimal point that was invisible, but now we see it, and we move it 2 spaces to the left. 1, 2. Now when we do that, we end up with an empty loop. And in that empty loop, we put a 0. So our answer is going to be 0.02 for 2 hundredths. Okay, and lastly we have percent to fraction. So percent, okay, you have to know, is always out of 100. Percent is always out of 100. Now, the cool thing is that the percent sign, okay, now we can just look at this as the 1 and then the 2 zeros, right? So it kind of changes to 100. So to write 4% as a fraction, all you need to do is write 4, which is a number, over 100. Okay, and then of course you have to ask yourself, is that in simplest form? Which it's not. So what number could we divide by to simplify? In this case, we can divide by 4. And if you didn't know that, if the numbers are both even, which they are, you can always divide by 2 first. So 4 divided by 4 is 1. And 100 divided by 4, think of quarters, is 25. That cannot be simplified, so your answer is 1 over 25. Okay, now we have 18%. Okay, so again, percent is always out of 100. So what we do is we write 18 over 100. Now, we can simplify this. Now, since both numbers are even, let's try to divide by 2. So 18 divided by 2 is 9, and 100 divided by 2 is 50. Okay, now you ask yourself, can that be simplified? This actually cannot. So your final answer is 9 over 50. Example number 3, 60%. Again, percent is always out of 100. So we put 60 over 100. Now, since both of these numbers end in 0, that means that they are both divisible by 10. So, 60 divided by 10 and 100 divided by 10. 60 divided by 10 is 6, and 100 divided by 10 is 10. Now, can that be simplified? Yes, it can. Let's simplify by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. Can that be simplified? No, it cannot. So your answer for that is 3 over 5, or 3/5.